Assalamu alaikum, students. The topic today I'm going to discuss Bohr's atomic model and its application. Before discussing Bohr atomic model, I would like to discuss first the weaknesses present in Rutherford atomic model. So, I'm going to discuss weaknesses in Rutherford's atomic model. Students, basically Rutherford put forward his theory about structure of an atom. For that he performed an experiment which is known as gold-foil experiment. So what is gold-foil experiment? Basically Rutherford took a thin gold foil and bombarded alpha particles. Alpha particles are the positively charged particles. When the positively charged alpha particle pass through the thin gold foil, then it has been observed that majority of the alpha particles were passes without any deflections into the gold foil. Meanwhile, some alpha particle bounces back with a very large angle. So, Rutherford concluded that atom has large empty spaces and a positive particle present inside the center of an atom, which is called nucleus. And he says that electron moves just like solar systems. A nucleus lying in the center of the atom, and electron revolves around it in their orbits. This is basically Rutherford's planetary model of an atom. So, according to Rutherford's a nucleus carries a positive charge. Nucleus is positively charged, and electrons are basically the negatively charged particles which move just like planets around the sun, and the orbits where the electron moves is known as orbit, the circular path around the nucleus, which is known as orbit. An electron move revolving around the nucleus just like a planet revolving around the sun. This is a planetary model of an atom which was proposed by Rutherford. But according to the classical theory, the revolution of the electron in a circular orbit is not expected to be stable, because being a charged particle, if electron moves just like planets around the nucleus, then the energy of the electron must be losses, because the classical theory says that if a charged particle continuously moves in a circular orbit, then the acceleration of the charged particle result in the decrease in the energy of the electron. It means electron would radiate its energy, means electron would lose its energy. So basically this was contradiction. This idea of planetary model of an atom was in contradiction with the classical theory. So if we are suppose that electron revolving around the nucleus, then the revolving electron will lose energy and finally fall into the nucleus. And if this were so happen, the atom should be highly unstable and hence matter would not exist in the form that we know. Basically this is the structure of an atom which was proposed by Rutherford. This one is electron, this is negatively charged particle, and this electron moves around the nucleus. This electron moves around the nucleus just like a planet, and then one stage will come. The electron will radiate its energy, the energy of the electron will losses, and then the radii of the orbit also decreases, and electron come closer to the nucleus, come closer to the nucleus, come closer to the nucleus, because nucleus carries the positive charge. The positive charge will attract the electron toward itself, and one time will reach, the electron will fall into the nucleus. And if electron fall into the nucleus, then atom will collapse. So in fact this would not true. So if an electron falls into the nucleus, then atom would not exist. So this is the basically this was the main defects which were found into the Rutherford's atomic model. And if an electron fall into the nucleus, then matter will not exist. So this was the main defects of Rutherford's atomic model. And another several defects also there. One of the defects of Rutherford's atomic model, Rutherford is unable to explain the atomic spectra as well. This one is the basically the spectra. According to Rutherford's atomic model, atom gives a continuous spectrum, but it has been observed through an experiment that atom gives a line spectrum, not a continuous spectrum. This was another defects of Rutherford's atomic model. Now comes to the Bohr's atomic model and its application. Bohr, a Danish physicist, studied in Rutherford's laboratory since 1912, and he successfully explained the atomic spectrum of an hydrogen atom, and he was awarded a Nobel Prize in physics. What are the Bohr's atomic theory? Bohr's atomic theory is the weaknesses in the Rutherford's model and the formation of blind spectrum were improved by Niels Bohr, who proposed a new theory to explain the electronic structure of an atom in 1913. This theory is based upon the following assumption. He says that electrons moves around the nucleus in a fixed energy, in a fixed circular path, and the circular path which we call orbit or energy level. And he says that when an electron moves in a circular orbit, its energy does not change. It means it not radiate energy, it will not emit energy, it will not absorb an energy. He says that when an electron moves in a fixed circular path, these circular paths are the energy levels, and these energy levels are also called orbits as well as shells. The first orbit, which Bohr called K shell, and the second orbit is called L shell, and the third orbit is called M shell. K, L, M, N, and so on. So these orbits have then fixed energy. So when an electron moves in these orbits, the energy of the electron remains constant. It does not emit or absorb energy. So this was the improvement which were made by Bohr's and Rutherford atomic model. Next point, according to Bohr's theory, Bohr says state the energy of the electron can changes only when an electron changes orbit. Very important point. It says state when an electron absorbs energy, it moves to higher energy level, and it moves further away from the nucleus. For example, this one is energy level 1. If an photon is incident on an electron, look at this. For example, this is an photon. For example, this one is in photon. This is an energy of the photon. For example, this energy in this photon is incident on an electron. Then electron moves from n equal to 1 to n equal to 2. It means electrons absorb energy and moves to high energy level, and the high energy level is away from the nucleus. And when it loses energy, look at this. This electron basically lost its energy. This one is losses. Okay, when this electron lost this energy, it will comes to its this electron will comes to its first orbit, and the emitted photon the energy can be seen as a light. So point number 3 is basically the energy of the electron changes when an electron changes orbit. When an electron moves to higher energy orbit, it absorbs energy, and when electron comes back to its initial orbit, then it will emit energy. Basically, this point shows this concept, and I am further explain this. The absorption, when an electron absorbs an energy and goes to higher energy level, this is known as excitation. excitation, and when an electron moves to its original orbit, then this process de-excitation. Similarly, point number 4, this process is basically a quantized process. It absorbs fixed amount of energy to move higher energy level, and when an electron comes back to the lower energy orbit, it will lose definite quantity of energy, and this definite quantity of energy is known as quantum. Basically, Bohr used the idea of Planck's quantum theory. According to quantum theory, energy can be emitted in the form of energy packet, and energy packet is known as quantum and also called photon in case of light. So electron lose definite quantity of energy called photon when it jumps from an orbit of higher energy level to a lower energy level. The emitted photon whose energy are fixed. And the point number 5, and the energy is emitted in the form of radiations, and the frequency of the emitted photon is directly proportional to the energy difference between these two levels. Very important point, this photon, for example, when an electron comes from higher to lower energy orbit and it emitted photon, for example this one is the photon, this is an energy packet, and I am discussing the frequency of this emitted photon. The frequency of this emitted photon is directly proportional to the energy difference of these two orbits, E2 minus E1. E2 minus E1. Basically, this equation is in accordance to the Planck's quantum theory. Planck's one of the points of Planck's quantum theory, the energy of the emitted photon is directly proportional to, as we noted, the energy of the emitted photon is directly proportional to the frequency of the radiation. Okay, this was one of the point of Planck's quantum theory. Okay, next point, a very important point. This point actually explains the angular momentum of an electron. Angular momentum of an electron, Bohr's says state, the angular momentum of an electron is also a constant, is also a quantized, is also a fixed quantity. This state, electron can revolve only in those orbits whose angular momentum is equal to nh upon 2 pi, or a multiple, an integral multiple of the factor h upon 2 pi. He says that, for example, when in first angular momentum of an electron in first orbit h upon 2 pi, the angular momentum of an electron in first orbit is 2 pi h upon 2 pi, h upon 2 pi. Similarly, angular momentum of an electron in second orbit is h upon pi, and in third orbit the angular momentum value is 3h upon 2 pi. Similarly, in fourth orbit, h upon 2h upon pi. So he says that the angular momentum of an electron is equal to nh upon 2 pi, or a multiple of integral multiple of h upon 2 pi. Look at this. This one is the angular momentum of electron in first orbit, n equal to 1. This one is n equal to 1. This one is n equal to 2. Look at this, n equal to 3. This one is angular momentum in n equal to 4. N's are the energy level. So first orbit h upon 2 pi, h upon pi, 3h upon 2 pi, h up to h upon pi. These are the integral multiple of h upon 2 pi. Okay, h upon 2 pi के इंटीग्रल मल्टीपल्स कहलाएंगे. तो इलेक्ट्रॉन की जो आपके पास मोमेंटम होगी, एंगुलर मोमेंटम, वो भी क्वांटाइज कर दिया था. ठीक है, यानी कि इलेक्ट्रॉन सिर्फ इन ऑर्बिट में रिवॉल्व करेंगे. ऐसा नहीं होगा कि आपको इलेक्ट्रॉन इन दो ऑर्बिट के दरमियान में आपको जो स्पेस नज़र आ रही है, यहाँ पर कोई इलेक्ट्रॉन की एग्जिस्टेंस नहीं होगी. ठीक है, तो ये जो स्पेसेस हैं, यहाँ इलेक्ट्रॉन आपको रिवॉल्व करते नज़र नहीं आएंगे, बल्कि इलेक्ट्रॉन सिर्फ वहाँ रिवॉल्व करेंगे जहाँ पर इलेक्ट्रॉन की एंगुलर मोमेंटम क्या होगी, फिक्स होगी, क्वांटाइज होगी. तो बेसिकली स्टूडेंट्स, दिस इज़ द बोर्स एटॉमिक मॉडल. तो आज के लिए टॉपिक इतना ही रखते हैं. इंशाल्लाह हम नेक्स्ट लेक्चर के साथ और आपको इस तरह के अच्छे से लेक्चर प्रिपेयर करूँगा. थैंक यू सो मच. अल्लाह हाफिज़.